Hello students, this session starts with the concept circular queue. In circular queue, elements are organized in circular fashion. So here, whenever rear end reaches to n minus 1th location and still empty locations are available at the front end of the list, in such cases, the rear end is reset back to starting location. Now such a representation is known as circular queue. Now it shows the diagrammatic representation of a circular queue. So when we observe this format, here elements are arranged in circular fashion. Now let us observe the way of creating a circular queue. First one, algorithm insertion of X. So this procedure inserts a new element X at rear position of the circular queue. Here, first we check whether the queue is overflow or not. For this, here we specify the condition as if F equivalent to 0 and R equivalent to n minus 1, R is another condition, F equivalent to R plus 1. If any one of these conditions are true, now total condition becomes true, hence we print a message as circular queue overflow, written from the function and if. Otherwise, first we check whether R reaches to n minus 1 location or not. If it is true, now R is set at 0th location. Otherwise, R is incremented by 1 and if. Now step 3, CQ of R. This location is filled with the inserting element X. Step 4, if F equivalent to minus 1, then F is set at 0th location and if. Step 5, return. Now deletion operation, algorithm deletion. Function is used to delete the front position element from the circular queue. Step 1, if F equivalent to minus 1, that means elements are not available. Hence we print a message as circular queue underflow, return minus 1 and if. Step 2, K equivalent to CQ of F. Step 3, if F equivalent to R, that means only one element is available. Now set F and R at minus 1. Else if F equivalent to n minus 1, then F is set at 0th location. Otherwise, F is incremented by 1 and if. Step 4, return K. Now, deletion operation completed. Now we go for display operation. So algorithm display. Function prints elements of the circular queue. Here, if F equivalent to minus 1, that means elements are not available. Hence we print a message as circular queue empty. Otherwise, here it depends on two possibilities. If F less than R, then we print elements from F to R. Otherwise, first print elements from F to n minus 1 and the remaining part is filled from 0 to R. The repetition process completed and if. Total comparison completed. In such a way, it is possible to display elements of the circular queue. The next one, Deque, is another type of queue. So a Deque stands for double-ended queue. It is a linear data structure in which elements may be inserted and deleted at either ends of the list. So at both ends, it is possible to apply insertions and deletions. Now observe, the the diagrammatic representation of a deck. So rear end allows insertions and deletion operations. Similarly, front end also allowed deletion and insertion operations. So here, based on the way of performing operations on a deck, it can be classified into two types, like input restricted deck and output restricted deck. So here, input restricted deck allows insertions only at one end but deletions at both ends of the list. Now it shows diagrammatic representation. So here we can insert elements at rear end only, but we can delete elements at both ends. That means front deletion is possible, rear deletion is also possible. Such a representation is known as input restricted deck. Output restricted deck. So output restricted deck allows deletions at only one end, but it allowed insertions at both ends of the list. This one diagrammatic representation. So here front end allowed deletion operations. Both ends allowed insertion operations like rear insertion and front deletion. So when we combine input restricted deck and output restricted deck, now this combination generates as deck. Next type of queue, priority queue. So a priority queue is a collection of elements in which every element has been assigned a priority such that the entire processing depends on the priority of the elements. For this, there are two priority rules, like first one, an element of higher priority is processed first before the lowest priority element. Rule 2. If two or more elements have same priority, then they are processed according to the order in which they were added into the queue. So based on these rules, elements insertions and deletions are possible in priority queue. So these are the four types of queues. Now we go for applications of queues. So queues are used in different application areas such as simulation, multi-programming environments, job scheduling applications, etc. Here, let us consider one application, CPU scheduling in multi-programming environments. So listen, in multi-programming environment, a single CPU is available which is necessary to serve more than one program simultaneously. So when this format arises, basic thing, based on the type of the jobs submitted for the CPU, it maintains three types of queues like high priority queue, medium priority queue and low priority queue. When jobs are submitted for processing, now these jobs are divided into three types based on their priority, such as high priority jobs, medium priority jobs and low priority jobs. Here high priority jobs entered into high priority queue, medium priority jobs entered into medium priority queue and low priority jobs are entered into low priority queue. Now CPU allowed high priority jobs for processing. So after completion of this process, now it allowed medium priority jobs. So after completion of medium priority jobs, finally it allowed low priority jobs. In such a way, a single CPU is capable to serve its service for multi-programs. So here it uses priority queue concept. Okay, thank you one and all.